So let's start from the first question. Going to cover practicing problems for final exam and for group activity 4. So find the margin of error for the given values of C. All right. So if our C, let me make it 90 instead of 95. Because 95 is everywhere, so it less 90 is there. Okay, so margin of error is equal. We start always backwards, so it's asking for margin of error. We are going to write down the formula for margin of error. Margin of error is equal Z critical sigma over square root of n. Now one would ask me, why do we use the critical and not t score, z score? Why not t score and z score we are using? Because our n is greater than 30, right? Okay, so let's plug the numbers. How much is z score? If you look in the table, 90% is 0.9, which is 90%. You are going to look in the positive z score, right? And let me see, it's should be for 90%, 1.645. And then we get sigma is 2.7 divided by square root of 100, which is equal 1.645 times 27 divided by 10. So how much will be the answer? You should get 0.44444. Okay, next one. Find the minimum sample size n needed to estimate mu for the given value, confidence interval, sigma, and error. Okay, this is the data we are given. So we need to find minimum sample size. Remember, we are going backwards. Minimum sample size is equal Z critical sigma over error squared. So we are going to plug, since we have 0.9, then Z critical is going to be 1.645, right, from the previous problem. So 1.645 times sigma is 8.4 divided by margin of error is 2, and all that square, we are going to get 48. Now, one thing I need to inform you, since it's a sample size, if you get, let's say, 47.01, your n, you're always going to round approximately to 48. This is not algebraic rounding. This is meaning-wise the rounding, because if you are dealing with a life existence, be it the birds, be it animals, be it human, how you going to get 0.1, right? You are not going to cut piece and move, right? So you are always moving to next, especially when it says minimum, which means it can be at least that much. So just rounding one higher, it's not going to do anything. All right? Next one. You are given the sample mean and the population standard deviation. Use the information to construct 90% and 95% confidence intervals for the population mean. Okay, I will do for 90%, and I believe you can continue with do same thing for 95%, okay? So I'll do 90%. And compare the widths of the confidence interval. If convenient, use technology to construct the confidence interval. a random sample of 60 homes, n is equal 60, let me write down right here, home theater system has mean price 121. Assume population standard deviation, which is sigma 17.3. Okay? So, what we do, since we need to construct 90%, our confidence level or interval, confidence interval 0.9, 90%. Okay, so again we are starting backward, so we need to find confidence interval for the mean. So population mean is greater than x bar minus error less than x bar plus error. So x bar we are given, right? All we need is find out a margin of error. So margin of error is equal z critical sigma over square root of n. So z critical for 90, 0.9, right? For 0.9 is equal 1.645. So this is going to be equal 1.645 sigma over square root of, might as well plug it. It's going to be, sigma is 17.3 and square root of n, it's going to be square root of 60. And you should get here 3.67. From here, x minus error, it's going to be 121 minus 3.67, which is going to give you 117.33. And x bar plus error, it's going to be equal 121 plus 3.67, and it's going to be 124.67, which means the interval, confidence interval, is going to be 117.33, 124.67. Okay, 95%, you can do it, right? All right. Next. Practically for 95%, margin of error, you should get, margin of error, you should get 4.38. And then x bar is 121 minus 4.38 and 121 plus 4.38, that's all. And you'll get here 116.62, 125.38. Okay, since might as well I'll finish. 116.62 here, 125.38 here. Okay, so the only difference here, so you put 95%. You find 95% instead of 90%. And it should be 1.96, I think. So plug the data, calculate, and you will get. Okay. So if we compare, what can we say? Look here. 117, between 117, approximately 124. Here we have 116 and 125. If we compare 95 and 90%, we can say the mean price in the more broader, see 116, 125, and 90 is tighter. The higher is confidence interval, the wider is going to be your interval itself. So the lower, the less is your confidence interval, 90, the tighter we get our interval, right? This one, if this one, let's do this way. if for 90 degrees, let's say this is 117, approximately 124, right? Okay, this is 90 degrees. For 95, we get 116 approximately, and 125. You see, we are getting wider, right? We are getting wider interval. This is 95 degrees. I mean, 95%. Okay. 95% and 90%. Okay? Next one. So, find the critical value for the confidence level where confidence level is equal to 0.8 and sample size is 10. All right? So, to find the critical value, sample size is 10. That means we are going to look in the in the t-score table. So we need to find t-score here table. Let's go down. I have here t-score table. All right, confidence level, here it is, 980. And sample size is 10, which means I'm taking 9. And I'm getting 1.383. 1.383, okay? So T critical this is also TC, T critical is equal 1.383. Okay, next one. Find the margin of error for the given confidence interval, sample standard deviation, and n is 27. Because n is 27 and we are given S, not sigma. If we would have sigma, then we would use z-score, no question asked. But because we have S and sample size is 27, then we are going to use formula margin of error is equal T critical times S square root of n. So T critical 0.95 we have 0.95, which is this one, 95, and at 27 we need 26. How far is it coming? Okay, I'm coming till here, right? 2.056. Okay? So T critical 2.056. So we plug here. S is 2.5. Square root of n, it's going to be square root of 27. Okay. You can do calculation, right? What do I get here? You are going to multiply 2.056 by 2.5 and then divide whatever will come out to 27. You can do math, right? Moving to next one. In a random sample of 7 people, okay, sample of 7 people, n is equal 7. The mean driving distance to work was 27 miles. So the average, x bar, is 25.7 miles. And standard deviation, because it's a sample, we put S, 7.8 miles. Assuming the population is normally distributing using t-score table, and not surprised because we are given S and sample size is less than 30, 99% confidence interval, 99% confidence interval for the population mean mu, for 99% mu is gonna be in the interval 14.8 and 36.6, and the margin of error 10.9. So this is for 99%, mu is this much, margin of error is this much. Through research, it has been found that population standard deviation of driving distance to work, so population of standard deviation driving to work, is 8.6. Using standard normal distribution with appropriate calculation for the standard deviation that is known, find margin of error. So we need to find margin of error for this sigma. Don't get confused. This is 10.9 margin of error is for 99%. And S, this is for S, 7.8. So we need to find margin of error and construct 99% confidence interval for the population mean. So we need to find mean, 99%. Okay, so let's start. First thing first. We need to find, so mu we know it's equal, greater than x bar minus error, x bar plus error. Yes? So x bar is given. We need to find margin of error first of all. So margin of error E is equal Z critical times sigma over square root of n. For 99%, Z critical is going to be 8 point, let me see. To find Z critical, what we're gonna do, we have confidence interval 99%, right? Here it is 99%. So if this is 99%, that's mean for these two tails here, areas, we're gonna be left 1%, right, together. Or per 0.5% each, right? So 0.5% is 0.005, 0.005, right? Okay, let's go to our z-score table, and I'm going to negative z-score because this is less than 50%. 0.005. Here we have 3 zeros. We need 2 zeros. 0, 0, here it is 47. I'm looking 0, 0, 5. There we go, right here. 0.005. That's gonna be negative 2.5. Negative 2.5, and here it is 7, 8. So negative 2.578. So this score is gonna be equal negative 2.57. It should be 5, no? 1 second. Yeah, 7.5. Yeah, between 7 and 8. So it should be 5. 7.5. 7.5. Okay, so from here, margin of error is equal, let me make this smaller. It's writing down way too big and then I don't have space. All right, so margin of error is equal, it's gonna be positive because we're critical, we don't use negative, 575 times standard deviation is 8.6, it's right here, 8.6, and divide by square root of n, 7. Okay, and you should get 8.4. You should get 8.4 for this one. And then from here, what we are going to do, we are doing x bar minus error, and then x bar plus error, right? So our x bar is 25.7 plus 8.4 minus 8.4, and x bar plus error, it's gonna be 25.7 plus 8.4. Well, you can add them, right? You can finish this and write down in the interval these two numbers. Okay, so this is the solution. Here we have next one, question number 7. Use the given statement to represent the claim. Write the complement and state which null hypothesis, which one is null hypothesis and which is alternative. Okay, if we are given sigma is equal 9, right? That's the claim is going to be, remember, null hypothesis, because null hypothesis always going to carry equal sign, and complement it's gonna be sigma is not equal 9. So claim I put in red color, so let me do this one also. Okay, next one. For the statement below, write the claim as a mathematical statement. State the null and alternative hypothesis, identify which one represents a claim. A laptop manufacturer claims that the mean life of battery for certain model is more than 7 hours. So more than 7 hours, that's an alternative hypothesis, which means, oops, blue color, H alternative is mu greater than 7. And complement, in this case, it's going to be mu less equal 7. Okay? And we already have it. We don't need this. This is the same thing. Well, I guess, okay. This should go here. And the claim here is going to be mu is greater than 7. That's what's going to be. And our claim is alternative 1. Okay? All right. Here it is. Which one is the claim? Right, this is our claim. Next one. For the statement, write the claim as a mathematical statement. State a null and alternative hypothesis and identify which represent the claim. Okay, so the mean daily attendance of part E is 19,000. That means the claim is gonna be mu is equal 19,000. Choose the correct null hypothesis. It is a null hypothesis because equal sign is in there. 19,000. And alternative is going to be mu is not equal 19,000. Simple as that. And the null hypothesis is the claim. That's right. Next question. Psychologists at the university compared the levels of alcohol consumption of male and female freshman students. Each student was asked to estimate the amount of alcohol, beer, wine, or liquor they consume in a typical week. Summary statistics for 125 males and 183 females are provided in this table below. Okay, for each gender, find 95% interval for mean weekly alcohol consumption. Okay, let's do for the male first. So, confidence interval. How much is our confidence interval? 95, right? Which means we're gonna get for Z critical, we're gonna get 1 minus 0.95 will be 0.5 and divide by 2, gonna be 0.25. Yes? Okay, 0.25. Let's go find out Z critical. Z alpha at Z critical, how much will be? 0.25 22 here 2451. Do we have anything closer? No, I think it's between these two, right? Hold on. I think I did something wrong here. Yeah, of course. 0.5. 0.025. Okay, going back here. 0.025, 2625 right here. No, it's a 2 zeros. Gee. 1 0, 0.0225 here, which means it's coming negative 1 9 and here it's gonna be 6, negative 1 negative 196. Okay, 1.96. All right, so our margin of error is gonna be Z critical times sigma square root of n. So this is equal, E is equal 1.96 times, how much is sigma? um, for male 13.52. And divide by 125 sample size. Okay, so then whatever number you get, it's gonna be x bar for interval, it's gonna be x bar plus error, right? X bar minus error. So, and you should get interval 1438 and 1912. Considering your x bar is 1675. So let me write down 1675. Let me make it easier for you. $16.75 right here. So if you take 1675, do minus this error, this one, whatever you get, and then you take 1675 plus that error. Okay, let me solve this one. Okay, let me do it. So let me see what we are going to get, and I'm going to count out loud. 1.96 times 13.52, that is equal 26. I'm going to write down, that is going to equal 26.4992 over square root of 125 over 11.180339. Okay, let's divide. 26.4992 divided by 11.180339. We get 2.37 approximately. All right. And from here, this would be equal, might as well, this would be equal, let me clean this, 1675 minus 2.37. So what we are getting, 16.75 minus 2.37, 1438. And if we add 2.37, we should get 19.12. Okay? Okie dokie. So let's do for female now. Let's do more female. We'll try to be more organized solving for female. So if you have any questions, you can find the answer. Well, let me do right next to it. Female. So Z critical gonna be the same. And what do we have here? Margin of error. It's gonna be Z critical 196 times, okay, Sigma for female, it's our standard deviation here, 1158 times 11.58, and divide square root of sample size, it is 183. Okay? So whatever number you get here, again, what you are doing, you take X bar, which is X bar here, 10.75 for females, 10.75 minus margin of error equal, and then 10.75 plus margin of error. This time you can calculate, right? Because here I showed you already how to do it. And you should get interval, the answer should be 9.08 and 12.42. Okay, let me see, I can figure out from here how much you should get your margin of error. 10.75 if I do minus 9.08. So 15 minus 8 is 7, here is 6, 10 minus 9 is 1. You should get 1.67. That's how much would be your margin of error. Okay? 1.67, and accordingly you should write down minus 1.67 and then plus 1.67, and this one you should get 12.42, and this one you should get 9.08. Right? Here it is. 9.08. So let me see if I can stretch it better so you can see better. Much better. All right. Next. Oh, that belongs to the same question. Okay. We're continuing working with these questions. Prior to sampling, what is the probability that at least one of two confidence interval will not contain population mean in estimate? Assume that two intervals are independent. So we are going to solve this the following way. Since our the confidence interval is 95%, right? Here it is, and it's identical for both cases, 95%. So what we're gonna do to find the probability that at least one of the two confidence interval will not contain population mean it estimates. Okay, what we want to do, the probability of at least one interval will not contain mean, it's going to be 1 minus probability for both. We have total both, right? Two of them. To know that at least one of them doesn't have it, we need to know that what's the probability of one interval can have that mean, or what's the probability of the other one interval can have mean. So if we want to know it won't happen, first of all, what's the chance that one of them will not have it? So we have to first know what the probability they both will have the mean. Therefore, to both of them, and first one and second one, remember that's a probability, and when we have and, we have to multiply by each other, which is going to be 0.95. Let's see. 0.95 times 0.95, because both have 95%, right, confidence. And if we want to know what's the chance they won't have the mean, I have to take 1 and subtract the complement. The complement will be they both have the mean, right? Therefore, we both multiply by 0.95, and the solution is going to be 0. Subtract from 1, you are going to get 0.0975. Okay? So, and one more question is here. It's asking, based on 2 confidence interval, what inference can you make about which gender consumes most alcohol on average per week? So, I put it down already here. So for the male, 14, 38, 19, 12. For female is this much. So for male is this much. For female is this much. So since all of the values in the male interval are larger than values in the female, and indeed, so higher lower end and higher upper end, right? Then we can say that male consumes most alcohol on average per week. Definitely more than women. Okay? That's all. I wish you good luck. If you have questions, please, instead of struggling, just text me or call me. Anyhow, contact me, and I will be right there for you to help you. Okay.